Hier kommt halt auch kein Wort. Ja, aber jetzt
the talk by Liina on cross-modal generality and step towards mechanism.
Thank you. Am I on? Yes. You can hear me? Yeah. So thank you very much. Thank you to the organizers for the invitation. It's been a very inspiring workshop so far. So this will be about composition in language very directly. And I'm going to try to organize this presentation and discussion around two questions that I think we probably all agree are fundamental questions about the nature of composition in natural language. And the first question we've sort of danced around a little bit already, but not really directly discussed. And that is, what is the internal architecture of linguistic composition? So is it the case that composition in language is some kind of a single unified operation, call it merge, whatever you want to call it, or is it computationally more subdivided? Linguistic theory on this kind of matter. So that's one question that I was trying to evaluate. The second question is definitely already on the table. So, so to what extent do the combinatory operations of language also operate in non-language domains? And so now the research that I've been pursuing for the past decade or so at this point is research using Magnetoencephalography or MEG that is sort of basic cognitive neuroscience research aimed at characterizing the spatiotemporal dynamics of the combinatory system of language. And now we've sort of been at it for long enough that we're beginning to be in a position to make at least some preliminary remarks about the questions in 1 and 2 here. And that's kind of those are the aspects of the research that I want to pull out for the purposes of this workshop. And so a lot of this is sort of very introductory material that I'm going to use as for this presentation. So all of the studies that I'll talk about here use magnetoencephalography, which has already been mentioned, MEG. So MEG measures the magnetic fields that are generated by neuronal activity outside the head. Its primary advantage over other cognitive neuroscience techniques is that it combines excellent temporal resolution, so millisecond by millisecond temporal resolution, with reasonably accurate spatial resolution. So spatial resolution usually like in the order of centimeters. So this is this is a single technique that allows us to characterize the spatial so to characterize linguistic computations both in time and in space. And it's uncontroversial that we also want to build some kind of model of these computations to be crucially in both time and space. Without both of those aspects, we do not have the model. So with MEG, we're able to go from the data that's collected in the MEG sensors to relatively straightforwardly to source space. And that's what I'll be talking about here, so independently localized source activity. And so now, instead of the kind of usual chronological presentation, I'm going to kind of cut through the chase right away and tell you sort of what is the overall picture that's emerging from this research, and then I'll try to focus on a few aspects of this. And so the overall picture goes something like this. The first localized region that we discovered to be sensitive to combinatorics is a region, is a ventral region of the prefrontal cortex, the medial region. So this MEG activity localized in the ventral medial prefrontal cortex, or activity in the medial parts of the orbitofrontal cortex. And we first discovered these types of effects in a body of research that was directly aimed at identifying neural correlates of semantic composition. So combinatoric operations that build semantics, but not necessarily syntax. So we're trying to keep syntax syntactic structures maximally constant and only very semantic complexity. What we know now, though, is that this kind of an effect, an effect that localizes in this region, is elicited pretty much whenever composition is varied. So now in our hands, this effect looks very general. It's strongly cross-modal, so we have data both auditory and visual, but also data from production. I will show you some production data that show this kind of generality, sort of cross-use generality. There's some reasons to believe that this activity is not reflecting the building of the syntactic structure. And this argument is very complicated and debated, but there's a couple different types of evidence that I can present for that. The first type of evidence is that first body of studies that we conducted, which were specifically designed to try to isolate correlates of semantic combinatorial operations. And so when we do that, so when we try to keep syntax maximally constant and only vary the semantic complexity, this is where we see the effects, and not really in other places. Secondly, this is an effect for which we have some evidence that it may generalize, outside language. So we have some evidence that this can be elicited even when the input is not linguistic. And in these stimuli, it's definitely the case that there's nothing like a free structure or anything like that. So then it becomes a question about how do you define syntactic composition in general. But for this, we know that if you have kind of conceptual meaning, but no phrase structure, you can get effects of this kind of thing. This activity is not related to the plausibility of the expression, so it seems to be involved in building the semantic representation, but not in the evaluation of the fit between that semantic representation and your knowledge about the world. So it's not an N400 related, but an N400 like effect. This is not something that I'll be talking about in any detail here. However, the timing is consistent with N400, so it is in that kind of time range. The second region that comes out prominently from this research is the left anterior temporal lobe. And so now with respect to this effect, we have evidence that it's probably not quite as general as the ventromedial effect. So in fact, we have evidence suggesting that it may be specifically restricted to environments where modification is happening. So when one predicate is modifying another one, like red sweater, as opposed to situations where you have argument saturation. So say the bird taking its direct object as a complement, like something like that. Similar evidence for cross-modality as for the ventromedial effect. For the left ATL, we don't have any current evidence for domain generality in the sense of showing that it's sensitive to composition in non-language domains. What we know, however, I have some preliminary evidence for, is that although this activity or this effect is automatic for grammatical sequences, it can also be recruited for sort of novel contexts. And by novel context, I mean a new type of word order, a non-native word order, given an appropriate task. So those are the at the end. So that's sort of the question on the timing is earlier than the ventromedial effect, in the 200 to 250 range after the onset of some critical work. The third player I will not be talking about at all in this presentation, and that's basically because I just don't have much interesting to say about it at this point. I'm labeling it as sort of angular gyro sheet region. It's really just this sort of more posterior region. Don't have any strong generalizations about that yet, so for the purposes of time, putting aside entirely here. And that's sort of that's kind of the primary picture that arises from our work. Now, you may be wondering what happened to the most famous thing here of the brain. So where is Broca's area? It should be somewhere, right? And so now, all I'm going to say here, but we can return to this in the discussion period, is that in our manipulations of composition, we do not see effects in the LIFG actually at all in these studies that are really targeted at basic combinatory operations. When we do a violation study, then we do see effects. But I'm not going to talk about any violation studies, and we hardly ever do those kinds of studies anyway. So we can return to it, but for now, I'm going to put it away. All right, so I'm going to go in this order. So I'll talk about the cross-modality first, and just sort of introduce a basic paradigm, and we'll take it from there. All right, so now this research diverges from the kind of majority research in the cognitive neuroscience and syntax semantics, in that we're really trying to target basic combinatorial operations that operate during natural comprehension. And that's different from most prior research, which has mostly used very complex manipulations, where it becomes exceedingly difficult to characterize or to be sure about the exact operations that the stimulus manipulation is varying. And so there's a huge imaging literature on sensor embedding and kind of related constructions, various kinds of dependency formation, that's sort of not, at least for linguists, not the natural starting point for studying composition anyway. And then of course the ERPs that are just completely dominated by these violation paradigms, and again their relationship to the composition of well-formed structure is clear. So we've in recent work developed a very kind of minimal paradigm that is really just aimed at studying a single step of composition. So we're really very simple. So we have the first word and the second word, and we're studying the combination of between two words. And remember, with MEG, we have enough temporal resolution that we can really just focus on this second word. And so that would be like the composition condition, and that would be contrasted with a single word condition where just the visual baseline is matched by preceding that word with a string of consonants. And that would be a non-combinatory context for the second word. So we know that this kind of stimulus doesn't really initiate attempts at flexible access. So that's sort of the basic contrast, and then there's some additional controls as we'll see in a minute. Okay, so how would this kind of experiment work? So this is a reading version of that kind of an experiment. So here I have my my combinatory condition, so just an object denoting noun preceded by an intersector color adjective, and this is the one-word control condition. And now, of course, you need some kind of a task if you just start presenting these subjects, a stimuli to subjects in the MEG, and without any kind of task, they will instantly fall asleep. And so this task, which is developed by Doug Beam, is actually it's a very nice one. It's sort of a comprehension task, but on these very, very minimal stimuli. So subjects read the verbal stimulus, and then after the verbal stimulus, there's the task stimulus, that's the picture. And their task is to indicate whether the verbal description matches the picture, and taking color into account when color is present. And so there's no judgments on the stimulus itself, but there's still sort of a comprehension task that really keeps them on task throughout the experiment. So now, of course, here we have still a compound, in this condition representing two words, whereas here there's just one word. And now, to try to control for that, we introduced a second task. So it's very difficult to come up with a kind of preceding word stimulus that really you sure could not possibly compose in any way with both. So people tend to try to combine things very automatically. And so in order to try to create a two-word condition where composition wasn't happening, we introduced a second task, and we're calling that the list task. And so now here, instead of indicating whether the picture matches the verbal description, the subject's task is to indicate whether the picture matches a preceding noun And in the two-word condition, they're presented with a list of two nouns, cop, boat. And in the one-word condition is exactly parallel to that one. So now you're reading cop, boat, and your task is to indicate whether the subsequent picture is either cop or boat. So that's the basic two-word design. And that's the combinatory condition. This is how it runs. So it's word-by-word presentation in the visual modality. And it's this kind of interaction that we're interested in as a possible correlative composition. So the two-word composition condition should show elevated activity with respect to all the three other conditions. And so now, as you now are going to be able to already predict on the basis of what I said at the beginning, that's exactly the kind of profile that we see in the left anterior temporal lobe between 200 and 250 milliseconds approximately, and then later in the ventromedial prefrontal cortex, revolving around 400 milliseconds, so slightly later. And that effect is replicated in the full brain comparison. And that's really the only place where we see exactly the right kind of interaction. So now, the nice thing about this paradigm is that it has the unique property that just by reversing the trial structure, so by presenting the subject with the picture first, we actually automatically have a production experiment that uses exactly the same stimuli. And that's very neat. And this, the cognitive neuroscience of syntactic and semantic production of multi-word utterances, like almost nothing about that. But now we're able to assess pretty straightforwardly of whether we are going to see a similar effect during the planning stage of an utterance such as red boat. So the nice thing about this is that, so obviously production studies are difficult to do because as soon as you start speaking, the electrophysiological signal is just lost. You cannot measure it. And it's also very difficult to get people to say a certain controlled expression. But this is a kind of very minimal domain of a limited set of shapes and a limited set of colors, so people really do say exactly what we want them to say, and the expression is short enough such that during the time that elapses from the onset of the picture to the onset of the utterance, there's very psycholinguistic evidence that the combinatory operations actually happen before you start speaking. So this is the size of the chunk that you sort of can plan ahead. And what we see, so this is specifically how this experiment runs, so it's really a kind of a production version of that. So this is the composition condition. People see these pictures and they're prompted to then utter red tree, green star. In this context, we cannot use the one-word control, so we can't have people just say tree or star, because the reaction times or the utterance times for those are much shorter than for the complex words. It just takes longer to plan two words than one. So the control condition has to be a two-word utterance. And so we use two-word lists. So now in the non-composition condition, you're seeing a red and a blue color, and you're supposed to name them from left to right. Then you obviously need a visual control task. These are two different objects, and we don't want to have graphics that are just reflecting that. So in the view task, the same visual displays are presented, and there's a task, sort of an occasional task, that the subject has to press a button whenever they see a gradient. So some of these, you probably can't see here, but some of the stimuli, like I forget the exact percentage, and every once in a while there's going to be a gradient stimulus, that's when you press a button. So they just have to kind of do the duties. And what we see in this task is exactly the same effects that we see in the comprehension task, or in the comprehension data, except in reverse order, which is a very nice property or a very nice finding, because obviously sound sense production is really good for comprehension. You start with your semantic representation and ultimately produce articulation, as opposed to the semantic interpretation being the end product. So now the ventromedial effect onsets first. So now that onsets around 180 milliseconds after the onset of the picture, and then that's followed by a left atrial effect. And both of these effects are, again, relatively sustained. And the view task does not show those effects at all, which is obviously critical. And the full brain data replicate that straightforwardly. So that's just sort of kind of an initial starting point, and the production data are sort of verificational, obviously. Well, most people would assume that the same combinatorial operations are operating both in combination and in production. And so now this point will be very quick, and hopefully that won't be too detrimental to this talk. So what about then the sort of more specific functional roles of these two effects that we've seen? So I told you that there's reasons to believe that the ventromedial effect is not reflecting the building of the syntactic structure, sort of traditional sense. And I'm saying that because in this body of research that we did some time ago now, we used a variety of manipulations where semantic composition was varied while syntactic structure was kept maximally constant. And to do that, we used a variety of so-called type mismatch or coercion expressions where two constituents cannot semantically compose directly without one of them shifting in meaning in some sense. And now if I start giving you examples, I'm instantly going to be out of time, so I'll do that. And so from these experiments, we saw that the ventromedial effect, which we labeled the anterior midline field in the sensor data, was systematically enhanced for these type mismatch expressions. But now later on, we found out that we get exactly the same effect for these red boat stimuli. So it's not. So this effect is not limited to these kind of exotic type mismatch configurations, but rather it seems to be more general, which is one reason I'm not going to focus on it here. And so now the question then is, how general is it? Now it's very general so far. And so now we've actually done a whole bunch of non-linguistic studies trying to assess, to what extent we get these types of effects, and most of them haven't yielded similar effects. There's one study where we did find exactly the same type of ventromedial effect, so I'll show you that. So this is really kind of in some sense, the simplest non-linguistic version of the previous type of experiment. So now it just uses the pictures by themselves in a sense. So this is now just a visual version of the red boat experiment, and where the composition condition is just, you're just looking at a colored object. So this would be a red boat. And in the no composition condition, you're just looking at an outline of a boat. And just to match for the sort of visual complexity, there's the amount of red, there's an equal number of red pixels as sort of a background to the outline. So it's what we really use. And the instruction is something like, when you see a colored object, indicate whether it matches a subsequent colored object, so the task structure is the same as before. When you see an outline, the subsequent shape will also be colorless, and the stimuli shape matches. So it looks something like this, and you can see. So now I'm interested in the imaging responses again to this first stimulus, and this is now the task stimulus. It's always going to be a different token of a boat, so it's not just a perceptual matching task. So you really, in some sense, sort of conceptualize the shape and the color, and then you perform this matching task. When you're in this task, you're not. It's just the color is just totally irrelevant. And with this design, what we have is exactly the same ventromedial effect that we see for the version of this experiment. And it's so this is that ventromedial effect. It's strikingly similar, so it's actually like identical in timing. So if you overlay the verbal data and the picture data, it's kind of astounding how similar the timing is. And there's absolutely no effect at all in the left ATL. That's again just the whole brain data that we always run this kind of analysis to verify that the localization is actually sort of on the right track. so now, so there's obviously lots of different interpretations that on the basis of these data are still open. And so I just want to walk through the hypothesis space a little bit. So one of the kind of narrower hypotheses would be that it reflects the composition of complex meaning, but the input can come from a variety of domains. It's really the composition of meaning, but it doesn't have to be a verbal input. A more kind of a somewhat broader, actually a lot broader, an interpretation would be a story such that it reflects some kind of more general mechanism of building larger representations from smaller ones. And the representations that they're building don't need to be limited to semantic representations. And then, of course, there's very broad hypotheses or interpretations that are still also at this point open. So you can say, well, you just need any task where that has sort of roughly this kind of structure, and then you'll get this effect. So two stimuli, you have to do something with the two stimuli, and then you'll get this effect. The broadest interpretation, I think we can rule out by a number version of this kind of paradigm that we've done. And so if we do just a simple addition version of exactly the same kind of experiment, we do not see this kind of Ventral effect, although we do see an effect in right interparietal cortex, which makes it seem like we have some reasonable findings there. So this last story, I think we can pull up. This is the number design, but I don't have too much time anymore, so I'll skip that. All right, so what do we have so far? So we see that the ventromedial effect extends to choroidal stimuli, and the left atrial effect does not. What we've also seen, although I didn't highlight this too much, is that neither of these effects is so automatic that it would be elicited for noun-noun compounds that are novel and presented in the context of a task that really discourages composition. So we learned that from the initial experiment where we presented noun-noun combinations, which is that's a alleged syntactic structure in English, so we have lots of noun-noun compound. This is not a noun-noun compound that we know of, but it certainly conforms to that syntactic structure. So if we present that kind of a stimulus in the context of the list task, where you really don't want to be trying to figure out, a bow that's kind of cup-like, such that you would get the noun-noun compound interpretation, but really you're trying to match the picture to one of these. In that situation, it seems that there's not an effect of composition for this kind of stimulus versus that kind of stimulus. So now, on the basis of those findings, now we have two questions. One of them, given the first bullet, is whether the role of the left ATL is language specific, or in some sense more language specific than the effect. And secondly, there's a question about to what extent these effects are actually automatic. Since we seem to have figured out one context where it wasn't automatic. And so now here's sort of our starting point for trying to investigate the bounds of the left ATL effect, and I will now be focusing just on the left ATL. So we've asked the question of to what extent we can engage this left ATL effect in the composition of interpretable but non-native sequences. And so basically we're just taking the original red boat materials and creating the reverse word order, so it's the word order. And these stimuli are then presented both in a task that's our old composition task, where you see that colored object after the phrase, and then in the context of a task that really does not require composition. You should be able to do that task totally without composing anything. So here's how that runs. So these are the stimuli. So there's the canonical order and the reversed order, again, with their one-word controls. And then the non-composition task, the task that you can do without composing, presents the color patch, the color, and the shape separately. Okay? So now I should be able to just read red bow and match that to the stimulus without any composition, similarly will affect. And then in the combined task, they're again brought together, which is sort of a natural composition task. All right, so here's what we found out from this. It turns out that in the non-composed task, where the color and the shape are presented separately, the combinatory fact, so the increase for the two-word condition, is only elicited for the canonical word order. So only for red both. For both red, there's absolutely no increase. So when composition is not required, only the canonical order engages the LATL. However, when we present these stimuli in the context of the composition task, now we actually have a main factor number of words. So now both the canonical word order and the reverse word order actually show the main factor. So when composition is required, even the reverse order engages the LATL. So, all right, so we have this sort of evidence for authenticity for these grammatical sequences, but then we can't seem to be able to recruit the same mechanism for the composition of the novel word order if the tasks are exact, so it also shows some flexibility. All right, so now I want to go just in the last couple of minutes back to this original question of what is the internal architecture of linguistic composition. And so here, here's a bunch of options. So there's many researchers have advocated that composition really should be thought of in a kind of unified manner. So that's obviously the view that Chomsky has been pursuing, even to the extent that movement is also just an instance of merge. And Crosby and Worstein have kind of similarly spirited proposal in the domain of semantic composition, and even cognitive neuroscience Hogwarts had been arguing for that kind of a story where there's a unification mechanism in the LING. But then if you take in your semantics 101 courses, you've heard that semantic composition can proceed by a set of different rules. So for example, we have one computational mechanism that performs argument saturation, so a more technical function application, versus a different rule that performs modification. So it seems a more articulated structure has also been proposed. And so now, so we wanted to kind of start getting some kind of initial, try to make this question empirical as opposed to conceptual, which is often the nature of the argumentation. And so in an MEG study, we contrasted several cases of modification to several cases of argument saturation. So the studies that I've told you so far have been very focused on these very simple intersective color plus noun combinations. And so now here we have 3 cases of modification, adjective noun, so that's the replication of the previous studies, but also adverb verb, so never jogged, and adverb adjective very soft. So 2 different types of modification. And then similarly, 3 different cases of argument saturation. So verb noun, eats meat, preposition noun, in Italy, and determiner noun, and here we use possessors for reasons that I don't have time to get to now. And so what we see here is that the left ATL effect seems to be specific to modification. And nicely, the effect really generalizes across the 3 different types of modifications. So it's not just an effect of adjectival modification of nouns, but there's some generality. The whole brain data tell us that the ventromedial, although the left ATL effect seems to be specific to modification, in these data, the ventromedial effect is observable. So again, some evidence for generality. And we didn't find any generalization about the argument structure cases, argument saturation cases, which is something interesting. Oh, what are we learning? So what we've learned so far is that even the most simple cases of composition, of course we can always debate the most simple case of composition, but even these very simple cases of composition elicit a complex pattern of neural activity comprising at least these regions. And so given these type of data, it appears that composition is neither monolithic nor localized to some single region. So that's sort of contrary to Hogwarts type model where there's a single operation in a single location. So what my guess is that the different components of this combinatorial network are likely to vary in their domain generality and also vary in their computational specificity. And so what we're seeing is this generality in the vmPFC, possibly extending outside language, and an automatic, flexible modification